Hi, my name is Harsha Patel, and this is my lab report for Physics 2212 at Tech. This lab is based on the lines of charge experiment, which follows up on the point charge model experiment that we did last week. The purpose of this lab is to use the data from our first lab, which is a point charge model, to calculate charges based on the lines of charge model, which is supposed to be more accurate because we're dividing the rod into multiple segments from which we are calculating the overall charge. So we're treating each segment like a point charge, so this is supposed to be more accurate. So the overall result is that we have a greater charge found in lab 2 on the pieces of tape, which is 7.01 times 10 to the negative 9th coulombs, versus lab 1, where we found the charge to be 1.37 times 10 to the negative 9th coulombs, which our lab 2 is more accurate. Some important concepts involved in this lab are Newton's second law, which is F equals ma, Coulomb's law, which helps us calculate the charge on a piece of tape, the law of superpositioning, so calculating the distributed charge, which is the charge based on the segments that we created of the tape, and we did so using the E field for a rod formula, and also included is the point charge formula, which we used in lab 1. Of the assumptions that we could have made for this experiment, the first one applies because we could ignore air resistance on a moving object, as once tape B floats in the air, it's static, so air resistance on a moving object is now irrelevant. The second assumption does not apply because we treated each tape as a line charge rather than a point charge, and did not concentrate the charge at the center of the tape. The charge was actually distributed along the length of the tape. And the third assumption does apply because we did assume that the charges on the two tapes were the same, and we have reasonably assumed this because the two tapes were charged in the exact same manner. This slide is a refresher on the original experiment we did with the tapes, but the thing that we changed is we divided each tape into segments and modeled each as a point charge, and these are important values from the original experiment with the length of the tape mass, and the distance included. So here are my calculations. We set the electric force equal to the gravitational force for this experiment. So electric force for a rod was found using the formula E equals kq over r square root of r squared plus L over 2 squared times r hat. So the following image is the calculations I did in order. So I multiplied the values step by step, and then I plugged them into that formula for the rod, and we found that the charge for a rod is 7.01 times 10 to the negative 9th coulombs. The following is the code for the computational model for the lines of charge. I just inputted my values from lab 1 and also edited some other values, including the distance, the length, etc. So this shows the results of the code. We found a magnitude of electric force and magnitude of gravitational force, and the green arrows are actually a depiction of the electric field of each point charge along the pieces of tape. That's a model of that. So essentially we took the integral of the function, and that can be demonstrated by the number of arrows along the tape, in this case the rod in the model. So based on this model, we found that this was more accurate than the point charge model because the tape was divided into countless finite sections. Errors came from the fact that in real life, charges likely were not equally distributed as we assumed at the very beginning, and additionally, charges on each individual piece are likely not equal either. So to answer a couple of the questions, if we had modeled each of our tapes as a single point charge, like in the previous lab, then the charge based on the point charge model would have been 1.37 times 10 to the negative 9th coulombs, as compared to the charge we calculated using the lines of charge model at 7.01 times 10 to the negative 9th coulombs. So we have a significantly larger value of charge in our lines of charge model, and this is because the values were found with different approaches. In the original lab, we used 1 point charge. We treated the whole tape as 1 point. Whereas in this lab, we divided all the tape into multiple sections, which is more accurate and it's more similar to the real world.